Hello everybody and welcome back. In this video we will be discussing problem 8 of the 2020 AIME I. The problem reads, a bug walks all day and sleeps all night. On the first day it starts at point L, faces east, and walks a distance of 5 minutes due east. Each night the bug rotates 60 degrees counterclockwise. Each day it walks in this new direction half as far as it walked the previous day. The bug gets arbitrarily close to the point P. Then OP squared is equal to m over n, where m and n are relatively prime positive integers. Find m plus n. So obviously we're going to have to draw a diagram for this geometry problem. So let's say the bug starts at point x. And the problem states that it walks a distance of 5 units due east. So east is going to be this way. That's going to be our first move, the bug's first move. And then it says each night the bug rotates 60 degrees counterclockwise. So 60 degrees counterclockwise is just going to be like that, and then 60 degrees. And seeing the 60 degrees, we think of 30, 60, 90 triangles. And we can form one of these triangles by just drawing this little base here, and then dropping this height. This is a 90 degrees, which means that this is 30 degrees. Now, how can we use this? The problem states that each day it walks in this new direction half as far as it walked the previous day. So on the first day, it walked 5 units. So on the second day, it would walk 2.5 units, or 5 over 2. So we know that this is 5 over 2. And using the properties of a 30, 60, 90 triangle, since the hypotenuse is 5 over 2, we know that the side opposite the 30 degree angle would be 5 over 4. And then over here would be just root 3 times this side, which is 5 root 3 over 4. And we can keep doing this process and see if we notice something that can help us. So for the next day, the bug would move like that. And then we can draw a 30, 60, 90 triangle again just by drawing that. And we know that this is going to be 5 fourths. Because the previous day the bug walked 5 over 2 units. Yeah, so we know this is 5 over 4. Well, this right here is going to be 60 degrees. And then obviously this is going to be 30 and this is going to be 90. From that we find that this is this length over here is 5/8, and this is going to be 5 root 3 over 8. And we can keep doing this, and you should notice a pattern. So for the first move, I'm going to tally like the number of the total x coordinate, the total of the x coordinate, and the total of the y coordinate. So for the x coordinates, and here we have the y coordinates. And you'll see what I mean by these two things in just a second. So on the first day, it moved 5 units to the right. And we have to be careful of the signs because if the bug is moving left, then the distance would be negative. So we have 5, and then we're going to add this 5 fourths because that's also in the horizontal direction. And then we're also going to add this, we're going to subtract this 5/8 because this is in the left direction or negative. So this is 5/8. And you should notice a pattern that we would keep going like this if you just continue this process. And then I'm just going to list the first 6 moves, and then we can see if we notice like a repeating pattern. Yeah. So 5 plus 5/4 minus 5/8 minus 5/8 minus 5/32 plus 5/64. And if you calculate this, this should turn out to be 315/64. Now let's move on to the y coordinates. So we first have this 5√3/4. And then we have our 5√3/8. And then if you keep doing the process, you get plus 0 minus 5√3/32 minus 5√3/64. And that's equal to 105√3/64. Now, if you're unsure on how I got these, I basically just kept drawing the bug's moves and then drawing these 30, 60, 90 triangles and finding the respective y and x coordinates or distances. Alright, so now that we have this is only the first 6 moves, but let's see if we notice that that this sum would have both the x coordinates and the y coordinates would have a after this cycle of 6 moves, then all of these moves repeat with a factor of 1/64. And taking that into account, we can use the formula for a geometric series, which is A/1 minus R, where A is the first term of the sequence and then R is the common ratio. So since it's the common factor is 1/64, we have A is 1 and then 1 minus 1/64. This turns out to be 64/63. And then we can multiply these by what we found over here, which was 315/64 and 105√3/64. So our new x coordinate would be 315/64 times 64/63, and these 64s cancel, so we're just left with 315/63. And then the y coordinates would be, we would do the same thing. We had 105√3/64. And then we would multiply by the same 64/63. These 64s cancel and we're left with 105√3/63, which is also 5√3/3. And then I forgot to simplify the x coordinate, but this just simplifies nicely as 5. So now we have the x coordinate and y coordinate for point P. So we can write point P as our x coordinate, comma, our y coordinate that we just found. The question asks, what is OP squared? And point O is where the bug started. Actually, this should be point O because that's what the problem states. I don't know why I chose point X, but it doesn't really matter. And to find distance, this is actually really simple. We can just use Pythagorean theorem. So we have OP squared is just 5 squared plus 5√3/3 squared. That's 25 plus 75 over 9, which gives 100 over 3, I believe. Yeah. And summing these, the numerator and denominator, we get our final answer of 103. Alright, hope you guys enjoyed. If you did, be sure to leave a like, subscribe, comment down what are the videos you want me to do, and I'll catch you in the next.